Hello everyone. In this video we're going to be talking about solving exponentials without logarithms. So in this case, of course, for problem number 1, we can take the log base 9 of both sides to get negative n by itself, but what we're going to do instead is we're actually going to change it so that it has the same base, and then we're going to set the exponents equal to each other. So looking at 9, that can be rewritten as 3 squared, but since 81 can actually be rewritten as 9 squared, we're going to just rewrite 81 as 9 squared. So let's write 9 to the negative n. And then 81 is divisible by 9. It ends up being 9 times 9, so that's 9 squared. And now that we have the same base here, the only way that these two things can be true is if their exponents are equal to each other. So we're not going to cancel out the base 9s here. What we're going to do instead is just set the exponents equal to each other. So it's negative m equals 2, and then the only thing we have to do to get n by itself is divide by negative 1. So m equals negative 2. All right, let's draw out another one that's a little bit more complex. So working with 64 and 16, I want to find a common base between them. So let's just go to Desmos and see what these things are divisible by. All right, we know that 16 is divisible by 4. So we know that 4 squared is 16. So let's see that if 4 can get us to 64. So we know that 4 squared is 16. Let's try out 4 to the third. All right, and 4 to the third will get us to 64. So we're going to try out this method, and then we're also going to try out another one after this. So we know that 4 squared is 16, and 4 to the third is 64. So let's rewrite these as that. Okay, so 64 is 4 to the third, and what we're going to do is we're just going to write the exponent right beside of it. So 3 times 2x minus 1. And we're also going to rewrite 16 as 4 squared, and then multiplied by its exponent there. Now that we do have the same base, we can go ahead and set their exponents equal to each other. So we'll have this. Okay, and I'm just going to distribute and then solve for x here. So 3 times 2x is going to be 6x, 3 times negative 1 is negative 3, 2 times negative x is negative 2x. Since I already have an x on this side, I'm just going to go ahead and subtract 6x from both sides. Okay, we're going to get negative 3 equals negative 8x. And then the only thing I need to do to get x by itself is divide by negative 8 on both sides. Okay, so x equals 3 over 8. All right, but there's also a second way of solving problem number 2, so let's try it another way. What I'm going to do is I'm actually just going to rewrite this problem down here at the bottom. Okay, and we're going to rewrite this with a base of 2 instead. So let's go to Desmos and figure out what we'd have to do to get to each of these numbers. So 2 squared isn't going to work. We know that's 4. 2 to the third is 8. 2 to the fourth is 16. So now let's see what we have to do to get to 64. 2 to the fourth is 16. 2 to the fifth is 32. And 2 to the sixth is 64. So let's rewrite these with a base of 2 instead of a base of 4. And see if we get to the same answer. So 64 is 2 to the sixth. And 16 is 2 to the fourth. Now that we've rewritten their bases, we can set their exponents equal to each other. So 6 times 2x minus 1 equals 4 times negative 2x. We're going to get 12x minus 6 equals negative 8x. And then whenever you subtract 12x on both sides, we're going to get negative 6 equals negative 20x. And then dividing by negative 20 on both sides, it looks like we don't get to the same answer. You get 6 over 20. But 6 over 20, 6 and 20 are both divisible by 2. And whenever, hang on, what did I do here? Let's see. That's negative 8, 12. I did something a little bit off, but you should get to 3/10, which is not the same thing. So I'm not really sure what I did here. I'll have to come back to it and see what happened. But let's move on to problem number 3. And this one we actually already have the bases equally to each other. So we're just going to set those equal. And we're going to solve for r in this case. So let's subtract 3r from both sides. That's going to give us negative r equals 2. And then we're just going to divide by -1 on both sides. So that means that r equals -2. Okay, so let me go back and see what I did here in this problem, because this should be equal. Oh, I see what I did already. That is actually not -2x, it's just regular x. So that's what I did there. Nice to know, nice to know. So that's not 2x, which means that this is just -4. Okay, and that would make this -16. Okay, and then that would make our answer at the very end come out to 3/8. Sorry about that. Okay, so match up, that's good. Glad that we went over that. All right, in the next video, I'm going to show you how you can do some of these with Desmos. Not all of them you can do in Desmos. Sometimes it doesn't work out exactly right, but sometimes it just happens to work out. So I will see you guys for the next video, and goodbye.